Hello and welcome. Let's look at another problem today called permutations. The question says that you're given an array nums of distinct integers and we have to return all possible permutations. The answer can be returned in any order. Let's start with understanding the question a little more. So you are given an example where the nums that you're given is 1, 2, 3. Permutation essentially is a new array of the given array where the elements can be arranged in any order. So for example, if you see the first output here, 1, 2, 3, here the original array, which is nums, which it is the answer itself. If you look at 1, 3, 2, here the second and third elements have been swapped to create a new array, which is 1, 3, 2. So on and so forth. You can clearly tell that each of these outputs has been generated by rearranging the elements of the existing nums. With that understanding, let's make a few observations. The very first thing about the outputs that you can say definitely is that you are using all elements of nums, right? The second thing that you can for sure say is that each element is used just once. The third thing, length of each output is equal to the length of the given array. So length of nums. Can we make any other observations? Yeah, maybe the final one. We do not reuse the element, so no repeats. Let's try and move towards the solution here now. As you might have already guessed, one way to solve this question would be via the approach recursion. But before getting there, let's try to rephrase our question. So here, given all these observations, let's try to rephrase the question as a problem of filling slots. So let's say when the nums that we had was of size 3, the problem can also be rephrased to say that we want to fill a list of array of 3 slots given the original array. In other words, the first slot can be filled by candidates 1, 2, 3. Similarly, the second slot can also be filled by candidates 1, 2, 3. And same goes for the third one. But what we have to understand here is that we cannot repeat a character. So which means if I have used 1 in the first slot, I cannot use 1 in any other slots. All right. With that understanding, let's try and create the tree. So let's say I need to fill these 3 slots and we'll be working with the given example 1, 2, 3. So here the example that I'm using is 1, 2, 3. So say you have a problem statement of filling these 3 slots with the given array of 1, 2, 3. What would you do? For the first slot, there are 3 choices. Either you can fill it with 1 or 2, or you can fill it with 3. Correct? So let's say for the first slot, which is represented by this level, I fill it with 1. Now, when you filled it with 1, the other 2 candidates that you can fill the following slots, which is the second slot, is either 2 or 3. Let's say we fill it with 2. The only candidate that you have now is 3. At this stage, the combination that you get, or the permutation that you get is 1, 2, 3. Similarly, if I go to the right of 1, the other candidate that we can fill the second slot is 3. If 3 is what we use to fill the second slot, the left over candidate which we can fill the third slot with is 2. So this becomes 1, 3, and 2. Similarly, we can complete the tree. So if you fill the first slot with 2, the second slot can be filled either with 1 or 3. If you fill the second slot with 1, the third slot can be filled with 3. And in this case, the answer you get is 2, 1, and 3. Similarly, 2, 3, and 1 becomes another combo. And we can quickly fill up this side of the tree as well. So 3 is the first slot, so you have 2 and 1 left. And here, if you fill it with 2, you have 1 left. The answer that you get is 3, 2, 1. And here, the only candidate we have left for the third slot is 2. The answer we get is 3, 1, and 2. So the leaves of the tree have all our answers. You can very well verify this. We get 6 different outputs, which is exactly what we have in our output here. I've recreated this tree to make it absolutely clear what we are doing. So if you look closely now, for each level, we are deciding for the subsequent slot. So for level 1, we select for first slot, and level 2, we select for the second, and level 3, we select for the third slot. Okay, if you now look more closely at each level, like for example, if you see the first section of the tree here, the first subtree here, we first add 1, and 1 in the following levels becomes static. The only thing we change is the second entry, 2 and 3. So the answer that you get, you'll always get 1 in the first position. The second entry changes, and the final entry is what we decide on our leaves. So now if we start populating our tree with a little bit of more data, we are actually trying to move towards the code here. This tree is a recursive tree. It's very clear. We have drawn the tree. We understand how the tree works. Let's now try to see how we can start moving towards the code. So let's say for the first root, you have, I just write this as like so. Say I have my the actual array nums, and then I maintain an empty array. So this is what will collect all our intermediary results. At each node, this is what will collect our intermediary results. So all the results that you see in the nodes, this is what we used to collect. So if I write this in the similar manner with DFS, and let's make one more change. Instead of nums, let's write this as the entire array, 1, 2, and 3. So now when we write on the left side of the tree, we add 1 to our intermediary result, and since 1 is already used, we only add 2 and 3 in our subsequent call. We only add 2 and 3. So this pattern here is very important now. Similarly, if I rewrite my this node in the same notation, the way it will be written as DFS, 2 is something that I've used here, right? So that means I'll add 2 to my intermediary result, and the candidates that I can further use is 1 and 3. Similarly, here also 3 is something we have used, and 1 and 2 are further candidates which we can use to fill up subsequent slots. So the things to note here is we are using one element at each node and making sure that that element is not passed in the subsequent calls. Now that is very important because we have to make sure that we do not repeat the element. Okay. Now that we understand how the tree for this problem is being created, we clearly understand how the two parameters that we chose to keep in our DFS function, they work. We understand that, which is that the second element here is the current element, which keeps collecting your intermediate result and gives you the final result in the leaf nodes. While you do that, the element that you choose has to be deleted. For example, here, since we chose 1, 2 and 3 were only passed, 1 was deleted. So with that in context, let's look at the code for this question. So I want to make sure that we understand how the tree gets created from the code. So this is the main crux of the code here, where you make exactly the number of calls. Like when you start, you make exactly 3 calls, which is equal to the number of the array that you've been given. And that makes sense, right? Because for the first slot, you'll be making 3 choices. Either you'll be using element 0 or 1 or 2. And that's exactly what we do here. In the DFS, for the 0th element, you'll add it to your intermediate element or the intermediate result, which is what we did. We added 1, which is happening here. And then you remove that element from all the subsequent calls. So here, if you think about this, here it'll look like that you remove the zeroth element, something like so. So here, if you know about how slicing works, 0 is the element which is excluded from here, and here we only pass from first element to 0, which means that the 0th element, which is 1, it'll get removed. The second part where we can think about is that the terminal solution, the terminal state for this recursion is when the length of nums becomes 0. And that's also something that we can observe here. As you keep going down this tree, you will eventually reach a state where your nums will have 0. So if we just complete that, here since we chose 2, your nums will become only 3, and this is your intermediary 1 and 2. And here, if you see, your nums will become empty, and your intermediary will be 1, 2, 3, which is the same. So this is where your terminal case hits. When your length of nums becomes 0, you just append whatever you have in your current, which is this. We just append that in our solution, and we exit from here. Now you can choose to add a return statement here, if that makes more sense to you. But focus here that the internal loop that we have written is running on length of nums. If this becomes 0, it'll anyways return, and this will not execute. I would recommend try adding a return statement here, and tell me how that works. You can use this code as it is. Try run this in Leetcode. It's a submitted solution. It should work. So it'll get accepted. And there you have it, folks. The last point I would leave you with is please try to create this tree for yourself along with function calls for a few examples, so that you're able to do the explanations really well during the interviews if you get this question. Thank you so much. See you in the next one.